Hey gang, today we're going to talk about adding polynomials. So first you probably want to know what a polynomial is. Well, an algebraic expression that contains one or more terms is called a polynomial. An expression is considered a polynomial if there are no terms with variables in the denominator and there are no terms with variables under a radical sign or like a square root. A polynomial with one term is called a monomial. So all of these are examples of monomials because there is just one clump of things put together to make one term. So 4 by itself is a term, x by itself is a term, 2x cubed all together is one term because the operation that's happening there is multiplication. They're all squished together. AB is also one term because they're being multiplied, so they're squished together. A polynomial with two terms is called a binomial. So all of those examples underneath are binomials because there is one addition or subtraction sign that's separating the terms. So x plus 1, x and 1 are both terms. A minus 5b, a and 5b are both two terms. C squared plus d, c squared and d are both separate terms. 2x plus 4y, 2x and 4y are both separate terms. A polynomial with three terms is called a trinomial. So here we see two addition or subtraction signs separating three terms. All right, so now let's continue with adding these. So adding polynomials is like combining like terms in algebraic expressions. You can choose to add vertically or horizontally. So here's the example, 5 plus 3x plus 2x minus 1. We can add vertically by lining up the like terms. So 3x plus 2x would be 5x, and positive 5 minus 1 would be positive 4. And we can add horizontally by grouping the like terms and then adding. So you can think of it either way. I'm going to do it some different ways as well. You do whatever way works best for you. So here we have that we're going to do the odds together. Now, something that's really important is that you also have to write this in what's called standard form. And when we're writing in standard form, we have highest exponent to lowest exponent. And sometimes they refer to the first time as being the lead coefficient or the lead degree, the highest degree. So we'll talk about that while we're doing this as well. So in this case, when we want it written in standard form, we need the x squared terms first. So I'm going to start by adding 2x squared and x squared, which makes 3x squared. Then x and 3x makes 4x. And last, negative 7 and 5 makes negative 2. So that is my simplified polynomial that I get from adding those two together. It is a trinomial because it has three terms. So I'm going to write trinomial just to make sure this stays in your brain. The lead coefficient is 3 and the degree is 2 because that's the highest degree of the polynomial. All right, let's take a look at number 3. So here again, same thing. We start with the highest coefficient or the highest degree, which is 2x squared, and there's nothing alike with that, so that just comes down. Then we have 5x, and that can be added to negative 7x. 5x minus 7x is negative 2x. And then we have 9 by itself, so it's just plus 9, making this again a trinomial with a lead coefficient of 2 and also a degree of 2. Since this is 2, that's the lead coefficient, and this is 2, that's the degree. Continuing, number 5. Oh man. We have x squared plus xy minus 3y, and then negative 6y plus 4x squared minus xy. So here we have two variables. Usually we want the first variable in the alphabet to be the highest degree. So we have x squared and 4x squared that we can add together, giving us 5x squared. Then we have positive xy and negative xy that are going to cancel each other out. And then we have negative 3y and negative 6y, which makes minus 9y. So this is a binomial. Lead coefficient is 5. and degree is 2. Okay, on to number 7. Same thing. Again, we look for the highest degree, and that's going to be our x squared term. So we have positive 5x squared and negative 2x squared, which gives me 3x squared. Then we have 6x and positive 3x, which gives us 9x. And last, we have positive 4 and negative 1, which gives us positive 3. So this is also a trinomial with a lead coefficient of 3 and a degree of 2. Okay, now number 9, we have a similar scenario where we're going to use the idea of adding polynomials. So we have the total number of students who traveled over the summer consists of 2 groups. Students who flew, that being F, to their destinations, and students who drove, being D. The number in thousands of students who flew and the number of students who drove can be modeled by the following equations, where N is the number of years since 1995. So write an equation that models the total number of students in thousands who traveled over the summer. Well, if we have some who flew and some who drove, the total would be those two combined. So 8n and 6n makes 14n. 7 and 14 makes 21. So our equation is t equals 14n plus 21. Then, if the trend continues, predict how many students will either drive or fly to any destination during the summer of 2015. So I don't have enough work down here, so I'm going to do it up here. So 2015 compared to 1995 would be 20 years later. So we're going to plug in 20. So t equals 14 times 20 plus 21. So t equals 280 plus 21. So t equals, nope, 301. So it would be 301,000 people. All right, so hopefully you understand the idea of adding polynomials. It's pretty simple and something that you've kind of done before with just combining like terms. All right, so you're on your own with the evens. I'll be around to check on you guys as you're working.